In this video, we're continuing section 1.6 on inequalities, and we are going to go over how to solve quadratic inequalities. Okay, so I want to get right into an example. So I want to solve for x, and then plot our answer on a number line, and then write it in interval notation. So part A, we have x squared minus 3x minus 4 is greater than or equal to 0. So to solve quadratic inequalities, one of the ways that we can go about doing this is, to think about the graph of this function, y equals whatever our quadratic is, and then draw its graph first. So I'm going to draw some axes. So I got my y-axis, my x-axis, and in drawing the graph, one of the things that's helpful to find out are the x-intercepts. So finding out where it crosses that x-axis. So to find those, we set y equal to 0, and if I plug that in, I get 0 for y equals x squared minus 3x minus 4. So to solve this, I can maybe first try to factor it. Okay, so it turns out this one does factor. So I will factor this quadratic. I'll get an x. I'll get an x. I'm looking for two numbers that add to -3 and they multiply to -4. So it turns out what works is minus 4 and plus 1. And now that it's factored and it equals 0, I can go ahead and say what x is. So from this first parentheses, I get that x is 4. From the second parentheses, I get that x is -1. So those are my x-intercepts. I'm going to plot those on my graph. So I got an x-intercept at -1. And then I got an x-intercept at 4. Okay, so I know the graph goes through those 2 points. The other thing that's helpful to know about a quadratic is, well, the graph of a quadratic is a parabola. It's either going to be an upward-facing parabola or a downward-facing parabola. And in this case, the leading coefficient, the number in front of the x squared, is technically a 1, and that's positive. And because of that, it's going to be an upward-facing parabola. So let's go ahead and sketch that in. So upward-facing parabola goes through those 2 points. Okay, and it turns out just having this x-intercepts in the shape of the parabola, that's going to be good enough for our purposes in answering the question. Because the problem wants to know, when is this function greater than or equal to 0? In other words, when are the y values of the function greater than or equal to 0? Well, that's when the y values are positive, or the whole graph is above the x-axis. So that's this whole section. These y values are positive. And then even at the x-intercept -1, that's where the y value equals 0, and that's allowed here with this inequality. So I will shade in that x-intercept also. But there's this other part of the graph where the y values are greater than or equal to 0. So I'll shade that in. So all of this, as well as the x-intercept, because there the y value equals 0, and that's allowed for this one. Okay, so now I'll put this in on a number line and then interval notation. So on a number line, I'd plot -1, I'd plot 4. -1 is shaded in, 4 is shaded in, and then all the x values to the left of -1 are working. Similarly, all the x values to the right of 4 are working. Interval notation now, it's going to be -infinity with the parentheses to -1 with a bracket because it's included. Union 4 with a bracket to infinity with the parentheses. Cool, and that's my solution. All right, so in part B, we are just flipping the inequality to a less than or equal to. So luckily, we can just reuse the same graph. So I got my y-axis, my x-axis. I know my graph looks like this. I'll label those x-intercepts one more time. So at -1 and then at 4. But now I want the y values to be less than or equal to 0. So they could be equal to 0, so I can be at these x-intercepts. I don't need open circles there. But then everything in between, those are where the y values are negative. So those are also included here. Okay, so I'll plot this on a number line. Then I'll have -1 and 4. Both of those are included, so close circles. And then everything between them also works, so I shade it in. In interval notation, I get bracket -1, comma 4 bracket. All right, that's my answer. Awesome. So let's take a look at another example. All right, so I'm going to flip the page, another example. Okay, so this time I have the quadratic negative x squared plus x plus 4. And first I want it to be just greater than 0. Okay, so I'm going to kind of get ready here, and I'm going to draw some axes. Draw some axes, because eventually I will need the graph. And I'm going to try to find those x-intercepts first. Let's find these x-intercepts. So I got to set the y value equal to 0. And I get 0 as negative x squared plus x plus 4. Okay. And if we try to factor this, it turns out nothing's going to work. It doesn't factor. So if it doesn't factor, I won't say pause the video. I won't count it down, but give the video kind of a quick 15-second pause and see if you can remember. Well, if I'm trying to solve a quadratic equation, it doesn't factor, what can I do? Think about it for about 15 seconds. Okay, so what we can do, I'm going to bring it back now, is we can use the quadratic formula. So I'll get x equals negative b, so that's negative 1, plus or minus square root of b squared. So b is 1, so 1 squared minus 4 ac. So the a is negative 1, and the c is 4. Okay, then all over 2a, so all over 2 times negative 1. That's my quadratic formula. So if I simplify this, I get x equals negative 1 plus or minus square root of, and I'm going to get 1 plus, this part becomes 16, so that's going to be 17, and then all divided by negative 2. Okay, so I can simplify these answers a little bit. So because of the plus or minus, I'm getting 2 answers here. One of them is negative 1 plus root 17 over 2, and the other one is negative 1 minus, divided by negative 2, and then minus root 17 over negative 2. Okay. All right, and the main thing I want to do to simplify this so it looks a little bit nicer is, I don't love having this negative sign on the denominator. If I were to move that up to the numerator, it would need to distribute to each of these terms. Okay, so I'm going to go ahead and do that. So that'll give me positive 1 minus root 17, and now it becomes just a positive 2 on the denominator. Doing the same thing for the other fraction, I'll get positive 1 plus root 17, and then over 2 for the denominator. Okay, so, these roots, these x-intercepts, they aren't as nice as in the last one. They aren't just whole numbers, but still, nonetheless, this can happen. I can get some stuff with square roots from my x-intercepts. Okay. Alrighty, so the smaller of the two is this. Sorry, I don't mean to erase. The smaller of the two is this one, because I'm subtracting the root 17, and the bigger is this one. So when I plot these, let me put a tick mark at 1 minus root 17 over 2. Let me put a tick mark over here at that 1 plus root 17 over 2. One of the ways that I know that this one is actually going to be a negative number rather than be a positive number is because, well, I know root 17 is bigger than root 16, and root 16 is 4. And on the flip side, root 17 is smaller than root 25, which is 5. So root 17 is like 4 point something. So 1 minus 4 point something is giving me a negative numerator. And that makes that fraction negative. Okay, leading coefficient. This time it's a negative 1, so I'm going to have a downward facing parabola. Downward facing parabola. Okay, and in part A, it asks me, well, I want this whole thing to be greater than 0. So I want my y values to be positive. That means, because there's no equal sign on this, I cannot include these x-intercepts. I'm going to put open circles there. And then I'm going to shade in all the values where the y is bigger than 0. So these are all the places where y is bigger than 0. Okay, so the problem says plot that on a number line, and then interval notation. I'm running out of room here, so I'll put it at the top. So I'll have 1 minus root 17 over 2, and then 1 plus root 17 over 2. Both of those are open. And then we're shading the stuff in between. So interval notation now, we get 1 minus root 17 over 2 with the parentheses, it's not included, comma, 1 plus root 17 over 2. Again, parentheses. Okay, there's my answer on a number line and in interval notation. Okay, let's look at part B. What if I flip the inequality and make it a less than? So again, I have the graph already, which is nice. I'm just going to use it. So the graph looks something like this. I had this one negative x-intercept, one positive x-intercept. It was downward facing. Let me label those again. This one was 1 minus root 17 over 2. This one was 1 plus root 17 over 2. But this time, I want my y values to be less than 0. Again, because there's no equal sign, there's going to be open circles at these x-intercepts. That's where the y value equals 0, but that's not allowed with this inequality. But now I want to shade in the places where the y values are negative. That's these parts of the graph where it's below the x-axis. And then also here, where it's below the x-axis, negative y values. Okay, let's plot this on a number line. Let's plot this on a number line. So 1 minus root 17 over 2, and then to 1 plus root 17 over 2. Open circles at these endpoints. And now I want the x values to be less than this negative 1, and then bigger than this positive 1. So in my interval notation, I'll get negative infinity, parentheses, comma, 1 minus root 17 over 2, parentheses, union 1 plus root 17 over 2, parentheses, comma, infinity with the parentheses. And there we go. Okay. So I want to end this video with one final example. But for this next one, I want to give you an opportunity to try it first. Okay, so this is going to be a bit of a warm-up question. Alrighty, so I want to have you actually pause the video for about 4 minutes this time to try these two problems. Pause it in 4, 3, 2, 1. Pause it and try these questions. All right, so hopefully you paused it and thought about how you might get these things started. Just to get myself ready, I'm going to go ahead and draw some axes. I know ultimately I'm going to be using the graph to help me with these. So let's just draw some axes for these. And I know I want to think about their graph, so I'm going to be looking at y equals x squared plus 3x plus 6. And we're going to want to try to find those x-intercepts first. So I set my y value equal to 0. 0 equals x squared plus 3x plus 6. And we could try to factor this, but it turns out this one also doesn't factor. So I can go to my quadratic formula. So I get x equals negative b. So negative 3 plus or minus square root of b squared, 3 squared minus 4. A is 1, c is 6. So 4ac, and then over 2a. 2, and then a is 1. Okay. So for this one of the things that I notice is that when I simplify this square root, I'll get square root of, this is 9 minus 24, which is negative 15. So I have a negative number inside of an even root, because a square root is an even root. So at that point, I don't even want to bother trying to simplify it further. That's just undefined. I can't take a square root of a negative number. So I tried to find x-intercepts, but I ended up getting an undefined value. This means, well, there are no x-intercepts. There are no x-intercepts. I actually need some complex or use some imaginary numbers to be able to express these answers. But I'm not going to have any real values for these x-intercepts. Okay, so, all right, so that means my parabola graph doesn't have any x-intercepts. Okay, is it upward or downward facing? Well, the leading coefficient is a 1 technically. There's a 1 here. So it's an upward-facing parabola, and there's no x-intercepts. What that would mean is the whole graph is above the x-axis. It's upward-facing, so I know it's going to be something upwards. But because it has no x-intercepts, I know the whole thing is above the x-axis. Because if it had been something like this, below it, well, eventually it would have crossed. But I know from my algebra that it couldn't have crossed because I got no x-intercepts. Okay. And you might notice that, I kind of drew it so this bottom point, which you might recall is called the vertex, is drawn to the left of the y-axis. There's a way I know that, but it's not a huge deal at this point. Later in, I think it's going to be chapter 2, we're going to review how we find a vertex. But for our purposes, it doesn't really matter. So even if you had drawn this thing, to the right, it doesn't really matter as long as you recognize the whole thing is above the x-axis. Okay, so I want this thing to be greater than or equal to 0. So I need to shade in the y values that are greater than or equal to 0. But all of them are. All the y values here are greater than or equal to 0. So I'm going to shade everything in. Everything gets shaded in, which is a little weird, but it could happen. So on my number line, I also shade in everything. All of these x values are going to work. They're all going to get the job done. They're all working. So in interval notation, well, all the x values work. Negative infinity to positive infinity, parentheses, parentheses. All right, I'm box that. So then what about for part B? Got the same function. So I know the graph already. It's going to be something like this. The whole parabola is above the x-axis. But now I want to know when the y values are less than or equal to 0. But there are no y values that are less than or equal to 0. So there's nothing to shade. My number line would be empty. My number line would be empty. So when the problem asks me to solve for x now and write it in interval notation, well, the best I can do is just say, well, there's no solution because there was nothing shaded in my number line to express an interval notation. And there's our answer.